Hi there, this is Mr. Wells, and in today's video we're going to be doing a lab to model Earth's seasons. Now before starting this lab, we should have viewed the Introduction to Earth Seasons screencast. That's the first link on your lab sheet. You should also download an app called Graphical Analysis, which is free from the App Store. As you saw in that first screencast, seasons can be kind of a tricky topic. We saw that video with the Harvard graduates, and even some of them were kind of very confused about what causes seasons. A lot of people think that it has to do with the distance to the sun, and we're going to find out that that's actually not the case. It's really, in reality, one of the biggest misunderstandings in all of Earth science. In this lab, I'm going to be your virtual lab partner. We're going to be doing an experiment comparing the difference between summer and winter here in Farmington. In order to do this, we'll be utilizing this setup that I have here. In the first setup, we're going to be modeling the winter solstice. As you can see, Earth's northern axis, which is tilted at 23.5 degrees, is pointed away from the light source, which is going to be representing the sun. During the winter solstice, which is the first day where we have the fewest daylight hours, the sun's directly overhead at the Tropic of Capricorn. All right, so in this lab, I'm going to be your virtual lab partner. So we've already got the lab set up. I've got a light bulb that's representing the sun. That's all hooked up through our pole and clamp system. I've got the light bulb pointing in the southern hemisphere. Notice how I have the northern hemisphere of the Earth pointed away from the light source. So we are, like I said, we're representing northern winter, and specifically it's going to be the winter solstice, or the shortest day of the year in Farmington, Minnesota. What I did was I hooked up a flexible temperature probe from my LabQuest, and I have that running up all the way through the back here, and I've got it hooked up so that it's at its closest approximation to Farmington. Unfortunately, we're not labeled here on the globe, so if you are doing this in person, you can put your temperature probe, make sure the tape isn't covering it up, and put that as close to the southern Twin Cities as you can. And that'll be a close approximation of where we are in Farmington, Minnesota. And so, again, we're doing our winter trial first, the winter solstice. What's unique about the winter solstice is that is the shortest day of the year. The reason that it's the shortest day of the year up here in Farmington is because during the winter solstice, sunlight is most direct in the southern hemisphere. Specifically, it's most direct at the Tropic of Capricorn. Now, the Tropic of Capricorn is 23.5 degrees, roughly, south latitude. So we have to go about 23 degrees down from the equator. Now, that 23.5 number might sound familiar because that's also the same number as the tilt of our axis. And it makes sense that if we didn't have a tilted axis, basically at all times the most direct sunlight would be shining at the equator. But because of that tilt, we are now shining our sunlight most directly 23.5 degrees south latitude at the Tropic of Capricorn. So I want to make sure that my light bulb is lined up with the Tropic of Capricorn, and it looks like it is. I might have to adjust it a little bit further down so that it's a little bit further into the south. The Tropic of Capricorn is labeled all around the globe, so you should be able to see it in multiple spots because the actual tropic wraps around the whole planet. And then what we're going to have to do is really quickly set up our LabQuest, and then we'll run the experiment to model winter in the northern hemisphere. All right, so I have this experiment hooked up to a LabQuest 2 device, which we'll be using in a lot of labs in this class. I'm going to be setting up the time so that our experiment is going to go over 10 minutes. Now, I have the duration set in seconds, so that's just going to be 10 minutes is 600 seconds. So here's how we'll do this. I'll take out my trusty stylus. I'm going to click on this gray box up here, and we'll set our duration to 600 seconds. 600, done. And our rates, we're actually going to set to 0.5 samples per second. What that means is that for every second, it's going to take half a sample, which means that every 2 seconds, we're going to get a piece of temperature data, basically. So I'm going to hit OK on that. All right, so I'm ready to start the experiment now. I've got my temperature probe and my light source at 25 centimeters apart. My light source is directly lined up with the Tropic of Capricorn, so I'm ready to do my winter solstice experiment. All you've got to do now is you'll hit play on the LabQuest, and we'll turn the light bulb on, and we'll let this experiment run for 10 minutes. So I'll see you back in 10 minutes. Okay, to set up our summer experiment, it's actually pretty easy. All we have to do is take our north pole, which remember it's pointed away from the sun in the winter, and we're literally going to flip this. Sorry if it sounds really scratchy, but we're actually going to flip the whole globe so that the North Pole is now tilted towards the sun. You still want Farmington, Minnesota to be lined up with the sun. What you're going to notice, so now in the summer solstice, so we measured the winter solstice, now we're doing the summer solstice, which is the longest day of the year that happens in June. That's the beginning of summer. Instead of the sun being directly overhead of the Tropic of Capricorn in the southern hemisphere, due to this variation in the tilt, now the light bulb should be tilted, should be pointed at the Tropic of Cancer. And so what you want to do is you want to double check that that's the case. It's interesting though, because if you turn this exactly over, it should actually already be lined up with the Tropic of Cancer. Why is that? That's because the Tropic of Cancer is 23 degrees north latitude, just like the Tropic of Capricorn was 23.5 degrees south latitude. So again, it lines up with that tilt of the axis. You have to imagine that in reality, the Earth is actually going around the sun. What we're doing is just simulating that by turning the globe over entirely. The one change that we're going to make that's really important is, and this is where the seasons concept gets a little bit confused, right? But we're actually going to make it so that we used to have the probe lined up at 25 centimeters away from the tip of the light bulb to the probe. We're actually going to push that just a little bit to 30 centimeters. We want to demonstrate, and that's not quite to scale, but we want to demonstrate the fact that even though the Earth is physically further away in the summer, and if that sounds confusing, it might be a good idea to review the Introduction to Seasons video, because that might sound counterintuitive. But it is true that in northern summer, the Earth is actually further away from the sun than it is in the winter. We're actually closer in the winter, further away in the summer. If you think about it, that's different in the southern hemisphere then. They're closest to the sun in their summer. But we're actually a little bit further away in our summer. And really what's going to be, I think it'll be pretty simple to understand. Once we model it, we confirm our data, confirm our hypothesis that it's obviously going to get hotter in the summer. We have to think about what specifically changed then, even though we're further away, to make this hotter. So I'm going to do that really quick. I'll set it up so that I measure this so that it's, let's say, 30 centimeters, so we're a little bit further away. So again, from the light bulb to the tip of the probe, 30 centimeters. That looks good. You want to make sure that we're lined up with the Tropic of Cancer, which it looks like we are. Again, that should be labeled all over 23 degrees north latitude. And so this should be good to go. And all I'm going to do, I've already have the second run set up, so I'm just going to hit play again. I'll turn the light bulb on. And so this will run, and then we'll come back again in 10 more minutes. All right, so we're done. It's been 10 minutes, and so I'm going to make sure that I turn the light bulb off. You don't want that running for any longer than it needs to be. And then, in order to see both sets of data, so this is run 2, we'll click on run 2, and I'm going to go to all runs. So now you have your run 1, which is in blue, and your run 2, which is in red. The last thing that we need to do is get this into graphical analysis. All right, so for distance learning students, the way that you're going to be able to get the graph is first you're going to have to go to Schoology. Now you need to make sure that you have Graphical Analysis, the app, already downloaded onto your iPad before you do this step. But if you go into our Schoology course page, you go to Topic 1, Distance Learning. This is where I'll always house our data sets for lab. So for this one, we're going to click on the Seasons Lab Distance Learning Data. What this is going to do, this is a CSV file. All that means is that this is going to be a file that we can open up in Graphical Analysis. So you got to click on this arrow on the top right. And then we got to go all the way over under More and go to Copy to Graphical GW. So right now, I know it looked like we had two lines when we did the lab. We just have to make sure that we enable that. So we have our time on the x-axis, but on the y-axis we should have two sets. Right now it's only showing us run 2. So if you click on that, you click on run 1 temperature. Make sure to do temperature and not time, because you want temperature on the y-axis and time on the x-axis. You can do it like that. And you can actually check run 1 time 2 so that you'll have all sets of the data. So this is what it's going to look like. It's a little hard to tell the colors apart, but I have two different colors, orange and red. And so what you're going to do now is upload this into your worksheet and we'll process the data. Before you screenshot this though, the one thing that we have to do is scroll across the screen And this is going to be true for distance learning and hybrid learning. You want to be able to fit all of the data around. If for some reason you're not able to scroll, it's probably because the thing got stuck. So just make sure to click the X and then try it again. So I've got all my data highlighted. And then one useful function of graphical analysis that we're going to use quite a bit is if you click on the bottom left here, it pulls up a menu, and we're going to do view statistics. And so then what this has is these are our statistics for our red line. You can see right here it's marked, and then our orange line. And it has useful data like the average. We're not going to need the average for this one, but that will come in handy in the future. What you guys are going to use is your minimum, maximum temperature numbers. And what's nice is it actually tells you at what time that was. So for example, on this orange line, the minimum temperature was 25.0 degrees, and that was at 2 seconds. The maximum was 36 degrees, and that was at 600 seconds. So that was at the very end of the trial. So now what you can do is actually screenshot this graph, and that's what we'll use, that's what you'll insert into your lab report for the graphical data right there on the first page.